We want to determine if, given 3 points, we want to determine if they are collinear. In other words, if they lie on the same line. And what we want to use to make that determination is what we know about vectors. So let's think about two sets of points here. I've got a point A, B, and C. And you notice those look like they are probably on the same line. I've got the point 5, 2, 7, 6, and 8, 8, the blue points. And then I've got these pink ones down here, PRS. And clearly those are not on the same line. But how could we use vectors to make that determination? Well, what I want to do is I want to take these 3 points and I want to make vectors out of them. So in other words, I want to take the point AB and view that as a vector that starts with initial point A and terminal point B. So let me put this vector in component form. Okay, so I've got AB. Now remember how we put it in component form. We take 7 minus 5, get 2, and then 6 minus 2 and get 4. And that's my component form for the vector. So now I'm going to go ahead and plot that vector over here, 2, 4. And it goes up to right there, and there's my vector. Okay, so that's that vector AB. Now, I want to keep the same initial point, but now I want to make a vector AC. Okay, so here's a vector AC. And here's what I want to do. I want to start here at A, of course, go up here to C. Okay, so A, go up here to C. And there I get another vector. Let's see, using the same thing, 8 minus 5, that is 3. And 8 minus 2 is 6. So there's my another vector, and I want to plot that. So I go over 3, 1, 2, 3, and up 1, 2, 3, 4, 5, 6. So I go up to right there, and here's my other vector. Here's that vector, okay? Now, it looks like those vectors are parallel. They might just be exactly on top of each other. It looks like they're parallel. In other words, it looks like that this AC vector may be a multiple of the AB vector. This is what it looks like. Now that's important. If that's the case, then that means there is some number K that we can multiply AB and get AC. So in other words, I could take 2 times something, 2 times K, and it equals 3. So I'm just looking at the x-coordinate here. Okay. Now, if I solve for K, that's K equals 3 halves. And sure enough, 2 times 3 halves does equal 3. Now, let's see, can we take the 4 and multiply it by 3 halves and get the 6? Because if we can, that means those vectors are parallel. So, let's see here. 4 times 3 halves, that's 2 times 3 is 6. Yes. So what we found is that AC does indeed equal 3 halves times AB. That means that AC and AB are parallel. Now you might wonder, well, what does that have to do with, do they lie on the same line? Well, the fact is, both of these vectors started at A. They have the same initial point. Vectors that have the same initial point and are parallel, they must be on top of the same line, right? They're at the same place, they're just different lengths. In other words, parallel vectors, they both start at the initial point A. Therefore, they are on the same line. So in other words, 5, 2, 7, 6, and 8, 8 are all on the same line. They're all collinear. So that's what we do. We make a vector. We make AB, AC, and notice, are they multiples of each other? And if they are, then those points are collinear. Now you can see here with the pink ones. These points are not collinear. And in fact, if we were to make vectors out of those, in other words, if I were to say, well, let's look at PR. PR is equal to 1, 3, right? And PS, now it's very important that we have the same initial point. If we have the same initial point, we've got 14 minus 10, that's 4, and 1 minus 2 is negative 1. Well, you can see here clearly there's no one number I can multiply one of these vectors by and get the other. For one thing, I've got a negative here. I'm not going to multiply, and so I've got a positive 1 and a positive 3. I'm not going to multiply that by some number and get a positive 4 and a negative 1. So these points are not collinear. Now, the same thing applies if we're dealing with triples. You know, here we've got ordered pairs. If we were dealing with ordered triples, it would be the same way. We have these three-dimensional vectors, and we still look to see if they're multiples of each other.